question 11, we're going to prove a whole bunch of stuff. And you will get really quick at these if you practice. We're going to need to know a few of our rules. I'm going to write 2 of them down straight away and the rest as we need them. So the first one I'm going to write is that cos squared theta plus sine squared theta equals 1. And the second one, tan theta equals sine theta over cos theta. So they're the 2 rules that we tend to use the most. And I'll write down the others we need in there as we need them. So like I'm going to have to go up and look because I honestly can't remember the others because I get away with these ones. So we've got 1 take sine theta, 1 plus cos sine theta equals cos squared theta. Now this is a classic A take B, A plus B equals A squared take B squared, yeah? So we're going to have 1 squared take sine theta squared equals cos squared theta. And we do know 1 take sine squared theta does equal cos squared theta. So I can just write cos squared theta equals cos squared theta. Left hand side equals right hand side. We always like to stop when the left hand side equals the right hand side. Okay, next one we're doing. This one. Okay. I'd like to remind you that if I have, x plus y squared, then that's x squared plus 2xy plus y squared, yeah? So here I'm going to have sine squared a plus 2 sine a cos a plus cos squared a. Let me move that over to the left a little bit. Equals, and then this right hand side I'm not changing. Usually you'll leave the right hand side as it is. But yeah, if you're in dire straits or if you can see it coming together, then you'll change both. So now, actually I've got to move this over. There we go. So now you can actually see already I've got sine squared a plus cos squared a. That's 1. So I've got 1 plus 2 sine a cos a equals 1 plus 2 sine a cos a. So left hand side equals right hand side. Okay, E. So I've got tan squared phi times cos squared phi plus cot squared phi times sine squared phi equals 1. Now, I'm going to start changing things. So I know tan squared phi is the same as sine phi over cos phi squared. We're timesing by cos squared phi plus, now cot squared phi is the same as 1 on tan phi squared. We're timesing it by sine squared phi, and we're saying it equals 1. Now this is the same as sine squared phi over cos squared phi times cos squared phi over 1 plus tan phi. Don't forget tan is sine on cos, so 1 on tan is cos on sine. So this is cos phi on sine phi squared times sine squared phi. You should already start seeing this because these will cancel out. So I've got sine squared phi plus, and this is cos squared phi on sine squared phi times sine squared phi. These will cancel out. Sorry, I should have chucked an over 1. So I've got sine squared phi plus cos squared phi equals 1. Yes, this does actually equal 1. Left hand side equals right hand side. So that used the top rule. Cos squared phi plus theta plus sine squared theta equals 1. Next question, that was E, so we're up to G. This one looks a bit nasty. Good. I like it when they get a bit mean. So we've got 2 times, now tan squared A is the same as sine squared A on cos squared A. I mean, you could write this in brackets with the squared outside first, but I'm not going to bother. And this is 2 times. Now, I hate turning things into sec, cosec, cotan. So I'm going to change this into 1 on cos straight away. Now, technically, that's the same as 1 squared on cos squared A. Take 3. So we've got 2 times... I'm going to... This is the same as 1 over 1. This is 2 sine squared A take... Now 1 over 1 is the same as cos squared A. I'm cross multiplying. I'm just using 2 steps. I'm going to do the same here. I've got 2 over cos squared A take 3 times cos squared A on cos squared A, which means here I've got 2 sine squared A take cos squared A over cos squared A equals 2 take 3 cos squared A over cos squared A. Same thing on the bottom, so I'll lose the bottoms. I'm going to get all the causes to one side, so I'm going to take this minus 3 cos squared A, I'm going to plus it on the other side, so I'm going to get 2 sine squared A, negative cos squared A plus 3 cos squared A ends up as plus 2 cos squared A equals 2. So this is the same as 2 outside of sine squared A plus cos squared A. So we get sine, I'm going to divide everything by 2, sine squared A plus cos squared A equals 1. And we know this is 1. So far, we've literally gotten through everything with just this and this. Let's see if we can keep this up. Okay. Oh. All right. This is interesting. Assuming cos squared x does not equal 0, I can literally divide everything by cos squared x. So I've got cos 4x on cos squared x plus cos squared x sine squared x on cos squared x equals cos squared x, which means I'm left with cos squared x, because this is saying like u to the 4 over u squared. Well, that's going to come out as u squared, isn't it? Plus sine squared x, and this side's going to come out as, it should have also been divided by cos squared x. It's going to come out as 1, and this is 1. What's another way we could have done that? I could have had cos 4x plus cos squared x sine squared x take cos squared x equals 0, so take it all over to the left hand side. Factorise out cos squared x. Equals 0. So this is cos squared x outside of, well, cos squared x plus sine squared x is 1. So this is cos squared x times 0. So 0 equals 0, left hand side equals right hand side. I like this right way better, just because we don't then have the restriction that cos squared x can't equal 0. Like, we're fine doing that. And that's question 11. Trust me, with practice, you will get good at these. Like, it's all about just fiddling around with it, seeing what you can do, seeing what you can turn into stuff that you already know, or just playing with it blindly until you end up with something that you're like, oh, but that comes out as 1.